The matrix below is the augmented matrix of a system of linear equations in variables x, y, and z. And so the system of equations would be one x plus 0y minus 1z equals 7, 0x plus 1y plus 2z equals 5, and 0 equals 0. So the leading variables are, I would say they are x and y. There are 3 variables in the system. The leading ones would be x and y. Is the system inconsistent or dependent? Now, it does not have to be either of those, but this time it is, because there is a tautology. This last line has all zeros, which means that we get the equation 0 equals 0, which is always true. And so there are an infinite number of solutions. The system is called dependent because instead of requiring 3 equations to define the solutions, only 2 are necessary. And so what we're going to do is we're going to take the first equation and the second equation and write them in terms of z. Usually I would do the second equation first, which says y equals negative 2z plus 5, and then the first equation, which says x equals z plus 7. Now we're asked to use t as a parameter for z, and so we also let z equal t, where t can equal any real number. So the general solution in terms of z is z plus 7, comma, I'm sorry, it shouldn't be z plus 7, it should be t plus 7. Because I'm now going to go back and replace the z's in equation 1 and 2 also with t's. So negative 2t plus 5 and t plus 7. So we've got t plus 7, comma, negative 2t plus 5, comma, t. That's our general solution. And putting in any value for t will give us another one of the infinite number of solutions. So let's look at the second example for this video. It says the augmented matrix of a system of linear equations is given in reduced row echelon form. Find the solution of the system. And now what reduced row echelon form means is that we have not only the triangular form, which has zeros in the bottom left corner, but we also have ones on the diagonal, and the part that is reduced is the fact that we have zeros in the triangle above the ones in columns 2 and 3. And so this augmented matrix actually stands for 1x plus 0y plus 0z equals 5, 0x plus 1y plus 0z equals 1, and 0x plus 0y plus z equals 4. And that's why reduced row echelon form is so nice, because we avoid using back substitution if we move all the way to the ones on the diagonal and zeros above the ones in columns 2 and 3. So in example B here, we also have reduced row echelon form, but we notice that our system is dependent, and so there actually is no 1 in position 3, 3, and so therefore no zeros above it. This is still said to be in reduced row echelon form because of the pattern of ones and zeros in this area in the first 2 rows and columns. So here we have that x plus 0y plus z equals 5, and y plus z equals 1. In this case, z is our independent variable. We replace it with t so that we get y equals the opposite of t plus 1, and x equals the opposite of t plus 5. So in this case, we get x equals the opposite of t plus 5, y equals the opposite of t plus 1, and z equals t as our solution. And part C of this problem, if we change it to a system of equations, would say x equals 5, y equals 1, and 0 equals 4. Since 0 equals 4 is a contradiction, there are no solutions. So the solution, no solution, system is inconsistent. And solution does not